Who else would it be otherwise than the old Gatekeeper? The old GK. Keeper of the gates, as they say. Well, just so you know how this is not an old video. I don't have a cigarette in my hand. You know, I quit smoking about 2.5 years ago. Just so everybody knows, you know, I know there's a lot of confusion because a lot of these videos that, or we put it this way, all of these videos that you've been watching for the last 6-7 months have all been videos that range all the way back till 5 years ago. But anyway, as I was sitting here looking at this very unique piece of equipment right here, you know what, I'm not even going to show this part of it. I just want to see in the comment section how many people even know what this is. I'm just going to show this section only. But anyway, I've had a lot of these questions. Hey, Gatekeeper, will you make a video showing what each part in the amp does? You know, what its functions are? Or Gatekeeper, will you make a video of how the RF flows through the amplifier, step 1, step 2, step 3? Yeah, I've gotten those questions a lot, you know. I'm like, yeah, I'm going to get around to it, man. You know, I'm going to get around to it, this and that. But after getting so backed up in work, I just hadn't got around to it as though I thought. So after looking through some videos, because, you know, every video I've released here, you know, up to 7 months or so ago, I've just been going down all of my videos that I've uploaded the last 5 years, picking videos at random. So something told me click on private, because I remember at first I was making some of my videos private instead of unlisted, because when you make them unlisted, I can share the link with people, you know, and they can watch them. Well, I think at first I didn't understand that, and I was making some of my videos private to where I didn't even know they were there, or unless I would scroll down and find them. So I put it on private and found a buku of nice little gems of videos that I had recorded and that I guess I never saw again. And I found these 2 videos basically explaining a 3-pill that we at the time, in 07-3 had just got done doing. I think it was a rebuild or something. But basically, I was just going through and just talking about each component in the video. So, I found a video already made, except you've got to keep in mind, this was 6 years ago. I believe 6.5 years ago to be exact. So, keep in mind, this is Gatekeeper explaining the functions and the parts in an amplifier 6 years ago. And since this is a 2-part video, what I did was use some download site to download the videos onto my phone so that I then can compile them into one video. What's the problem, son? What's the problem? Jack, come here. Come here. What's the problem, sir? What's the problem? Huh? Could you hold on for a second? We're going to go bye-bye here in just a minute, okay? And you calm down too, friend. See how he turns his head. He's like, I'm in trouble. So I'm going to go ahead and compile these videos. I just want to do a pretty video real quick to say that I'm probably going to have to cut myself in a time or two, because I do see there's a thing or two that I was explaining that I don't even agree with now, or some that I needed to add something to, or a couple of things I may have said wrong, because that's one good thing I am very good at, is misspeaking, stuttering at times, and saying things wrong. I'm human, you know. So anyway, so here's the video. It ain't nothing high-tech. It ain't nothing extravagant. It's just me sitting in front of a 3-pill talking about what each component in that 3-pill does as good as I can at the time, which was 6 years ago, which was only 4 years into the hobby. So I was only 4 years into the hobby at the moment. Maybe 4.5. Maybe 5. We'll give it 5, but no more than 5. But I've learned a lot since then. But anyway, here you go. Thought I'd do a quick pre-video. We'll see you. Enjoy. All right, here we go. I know you've been waiting for this video for a while. All right, I'm going to use this amplifier right here to describe how RF flows through this amplifier and how it's how the RF is amplified. Okay, and first, before I start, you need to look at this as two separate amplifiers. Or a better way to say that is two separate amplification stages. Alright? Look at that as simply a one transistor amp. A one pill amp. Okay? Look at that as a 2-pill amp. I could take that and put it in a box by itself and it would be a 2-pill amp. I can take that and put it in a box by itself and it'll be a 1-pill amp. And I can hook them both together and they'll do the same amount of power that this amp right here is doing alone, if tuned correctly. Okay. Alright, we're going to start from the top, which is from the back. Okay, you got your input, you got your output. Your input is from your radio. Okay, we're dealing with a 50 ohm signal coming from your radio, which is also called your exciter. Alright, it comes from this SO239 right here through here to this lead on this relay. The way that you look at a relay is all it is a simple double pole, double throw switch. The only difference of this and a regular manual double pole, double throw switch is this right here is electromagnetically turned on and off with a coil inside the relay that's energized with a DC signal. So once that coil is energized, the relay flips. The poles leave from touching the poles it's touching and touches the next poles that it wasn't touching. And then when it's de-energized, it flips back to where it was. As this box sits barefoot, you follow this right here to here. This lead right here, and here's another way that you can look at this relay. It's two separate switches. This relay is two separate switches. Two single pole double throw switches, which equals a double pole double throw. Alright, so look at this as two separate switches. That's why we have this jumper right here. The RF comes in right here. With this relay sitting still, this lead on the relay is touching this lead. Okay. This lead right here is touching this lead. That's why we have this jumper here, okay, to connect each side of the relay together when you're on barefoot. So when you're barefoot, the RF signal comes through the white wire, okay, and since this lead is touching this lead, the RF goes from here to here. And since we have a jumper, now the RF flows through this jumper over to this side of the relay. Alright, you see this relay is turned off, so this is touching this. Now the RF flows from here to here, out the amp, over to your antenna, or whatever's behind your amp. That's how it flows barefoot. Next, being amplified. Here's your keying circuit. It's kind of hard to see. You can watch my video on how to make a keying circuit to understand this a little more, y'all. But basically, all this keying circuit is doing is, the way the amp sits when the switch is turned on, is there's now power going to the positive of the switch. Okay, and that right there is over here. The positive side of the coil is over here. Most relays don't have a polarity. You can use either side. This relay does not have a polarity. Okay, they're just using whichever side they want to use. So positive voltage is sitting over here. I don't know why it would say I only have 5 minutes.
Well, that was weird. We lost all communication for a few minutes there. Skype sometimes does.
Hold on, I'll be back.
I think we have another caller on the line. Who are you?
I figured out what was going on. It was recording on my, I got 3 SD cards in this phone, man. I take a lot of pictures. So I got to flip back and forth from the SD card sometimes. I was on my first SD card. So now I got 23 minutes on this one. All right. Let me throw this damn cigarette out here, man. All right. So, as this sits, when I turn the switch on, there's a positive voltage sitting on the relay. But the problem is there's no negative voltage. Or there's not a ground. Let's put it that way. There's not a ground. The ground's on this board. That's where the ground is soldered to, okay? So it needs a ground for this relay to turn on. Well, that's what this keying circuit is designed to do. All this keying circuit is another switch. But instead of this switch being turned on with power, this switch is turned on with RF. So as soon as RF flows through this keying circuit, it makes the transistor of the keying circuit turn on. And what that does is it touches the left leg of the transistor and the right leg of the transistor touch each other, just like a dang switch. And when that happens, the ground connects to here. So now you have a ground and this relay actuates, it keys. At this point, like I said, look at this as 2 switches, 2 single pole, single throw switches. If you cut that right there, you would have no way for the RF to flow when it's on barefoot. But if you cut that right there, it'd still work when you key. Okay? And you're about to see why. Like I said, with this relay sitting still, barefoot, this lead touches this lead right here, that lead touches that lead. Both leads switch at the same time. So when this relay turns on, now this lead touches this lead. This lead touches this lead. You would call the middle leads right here your common leads. So this lead right here is the pole that's being thrown back and forth on both sides. You could have a 3-pole double throw, 4-pole double throw. It don't matter how many. All the common leads are thrown together. Try to make it hold good. So as it rests on here when the relay's off. When it's keyed, the common lead now touches here. And here's your RG316 coax. So now the RF comes in. The RF senses a 50 ohm load at this point from the relay. If it didn't, your signal would not be able to flow because it needs a 50 ohm load. Okay, because if it didn't see a 50 ohm load at all the power you're trying to put in the amp will be reflected back to you. So since it senses a 50 ohm load or very close to it, this lead is now touching this lead. This lead's now touching this lead, and this is how it's seeing the 50 ohm load from your antenna. This lead touches that lead. That lead's hooked up to this output transformer. So the RF comes in, now to this lead, down this lead, travels down the RG316 coax, up right here to the middle wiper of the 100 ohm variable. So now this variable is now an input attenuation pad. All this is doing is putting resistance on your signal that you're putting into the amp. So if you can put resistance on your signal and knock the 4 watts or 5 watts down to 3 watts or down to 2 watts, that makes your output of your amp do lesser because you're putting less into the amp, okay? Now I'm just going to show you how the RF flow through the amp on this video. We can make another one later on and get a little bit deeper. But basically this is a 100 ohm variable, 2 watt. What this 100 ohm over here does, on the AC side of things, this 100 ohm creates a voltage divider circuit with this 100 ohm here. So 100 plus 100 equals 50. So it creates a 50 ohm variable. And the reason why another reason why you're doing this too is to double up on your power. See, I think a lot of people don't really understand what this 100 ohm over here is doing. And if you notice, a lot of times you'll see a 100 ohm 2 watt that's blown to hell and back from people turning their variables down a little bit, because it just appears that even though it's a 2 watt they're using, it's still a little bit weaker than the actual variable itself. So with me using a 5 watt here and a 2 watt here, they come together as a 7 watt. And when I say 7 watts, we're not talking about RF wattage, okay? It comes to a 7 watt 50 ohm resistor. It makes it more stiffer, more stronger. I think if a lot of other builders understood that, they would be using 5 watt resistors as well right here. From all the other ones, it seems like I'm the only one that utilizes this. I have seen other people do that. You know, don't get me wrong. I'm just talking about the main people. So now you have a 50 ohm variable here, and you can actually put a ohm meter right here to see this. All right. So the RF comes up through here, leaves from this wiper through the variable to this wiper right here on the right, flows through this resistor. Alright, this is a 47 ohm resistor, which is very common for a 3-pill, because at this point what we're doing is we're backing down the signal even more when it flows through this resistor, because it seems a lot of the times when using a 2290 or whatever, driving two 2879s, that the 2290 is just a little bit too much still for the two 2879s. And your dead key is quite high, so you need a little way to back that down just a bit and soak some of that power up, okay? So that's what this is doing right here. So if I had this variable right here turned to the middle at 25 ohms, then that's 25 ohms plus 47 ohms of resistance on the signal. So it comes to this signal right here. You got your 100 picofarad cap. This right here now is your input tune, okay? This is working in conjunction at this point to begin to start to break that 50 ohm signal and match it up to this transformer's coil, okay? Because at this point, we are now going to be changing our 50 ohm signal down to a different ohms. We're going to be going smaller now. I don't know the exact ohms without looking at some reference notes I have, but now we're going to be changing the 50 ohm signal to a ohms that this transistor can handle. Because this transistor does not take a 50 ohm signal into it. So we had to drop it down, okay? And that's what this capacitor is helping with. It's the tune of the input of the driver section. If you look at this as a 1-pill by itself, this is the input of the 1-pill amplifier. These 3 caps right here, see, we're using broadband transformers. These broadband transformers are designed for 2 transistors. What these 3 capacitors right here, they are mimicking the amount of capacitance is on the input of this transistor. Okay? We're talking about actually the amount of in a sort DC capacitance in a sense. The actual input capacitance of this pill, we're mimicking it over here. So the circuit thinks there's a 2290 over here as well. That's what these 4 caps are doing right here, these 4104s. They're mimicking the output capacitance. Okay, so that right there is 400,000 picofarad. 400,000 picofarad, which is .4 microfarad. This right here is 3,000 picofarad, 3 1,000s. All right. So this right here is making the circuit think there's another pill right here. This right here is what you call your feedback circuit. It's 100 ohm. All right, watch this. This is called a push-pull circuit. Okay, to make this pull-pull circuit more balanced, it actually needs a little bit of its output put back into its input. I know it sounds crazy, but that's the way it works, and that's what this feedback circuit is doing. This 100 ohm is taking some of the output that is being made. It sends it through this 100 ohm. Now this is AC at this point, okay? It sends it through this 100 ohm in series, okay? And then the AC flows through this capacitor. So at this point, this capacitor right here is just taking a sample of the RF from the input. If you didn't have this capacitor on here, it wouldn't be pretty. Okay, so this capacitor is somewhat helping to limit the amount of RF along with this resistor that's going to be put back into the input. So your output signal flows through the feedback back. I know I'm getting a little technical now, but RF is flowing through that. There's your bias resistor, a 10 ohm. You'll see that blow too a lot of times when a pill blows, okay? That right there is actually being put on the bias of the, for this is a class C, so that right there is actually being in conjunction with the RF that you're putting in it for the bias of the pill. Now here's another neat thing. The RF signal that is being put into this transformer, if you follow it, this purple wire, okay, this purple wire wraps around the transformer like this, okay, 5 times, and then the other side of the wire solders to ground right here. So this wire is not in no way physically connected to this pill. The RF flows from this variable into this purple wire, wraps around the transformer, solders to ground. This wire is not physically soldered or connected to this transistor. Now this is the neat thing. This is where you have an electromagnetic pickup. With this wire being wrapped around these cores, the RF creates an electromagnetic field. Because of this circuit being the way that it's tuned, the transistor is able to actually pick up this electromagnetic field, and it almost acts as an antenna in conjunction with the output transformer. This and this is acting like an antenna in a sense. You are winding these to pick up the RF as an antenna in a sense. Creates the electromagnetic field, flows through the transistor, and now you have DC on the RF signal as well to make this transistor be working. There's a choke, comes from the hot bus right here to the back of the transformer. Okay, this is where the DC is going on the back of the transformer. This is where the transformer is grounded. You'll also see sometimes that this input transformer is not grounded. It's all up to the builder how he wants to do that. We won't get into why. This capacitor here, see, these transformers aren't perfect. What this capacitor is doing is it's making sure that no RF is leaking. It's minimizing on the leakage of the transformer. So it's also helping to boost the magnetic field on the output transformer. So it helps with the leakage, and because of it helping with the leakage, is boosting the magnetic field on this transformer. So this transformer has 2 wraps. Okay, now the reason why the wraps are different, this is all just like a transformer on a DC power supply. It's a ratio. Okay, and it all has to do with transforming the signal to go in the pill, out the pill, transform the signal to another sub-ohm level. Let's go ahead and flip the amp this way at this point. Now we come out, blue wire right here, wrapped around, this side's the ground, goes out. And you will see we have a 120 cap that goes from here to the ground. That's all I'll on the pill strip. That's from the collector to ground. All I will tell you is that it's part of the tune. Okay, it's shunting a little bit of the RF to ground. We won't get into that. But there's a capacitor right up under this resistor, which is the output tuning cap for the transformer. For this output transformer, that is the output tuning cap. At this point, if this was just a 1-pill amp, at this point, this wire would continue over to the relay, then out the amp. But now, since it's not a 1-transistor amp, it's a 3-transistor amp, now this 1-pill stage is tuned by itself. Now we need it to continue over to the 2-pill section. All this resistor right here is doing, it's a very small resistor. Okay, the flash is about to turn out. Okay, battery about to go dead. All this resistor is doing is just kind of slowing down the RF just a tad bit. Not much at all, just a tad bit before it enters into the coil of the input transformer of this transformer. Okay. Now, don't even look at the 1-pill section no more. We are gone from there. Now let's look at the 2-pill section. As you see, this capacitor right here, which should be a 180 puff, 180 picofarad, yep, see it? That is the input tuning capacitor for this transformer right here, on the input transformer. Same as the input cap on the input of the 1-pill section. This is the input tuning cap. Alright, this is helping to make sure there's no reflect. It's going to be being reflected back this direction towards the 1-pill section, and that all of the RF that the 1-pill section is making is going to be entering into the 2-pill section. We've got a 330 here, 1000 here. These are both doing the same thing. It's helping to make sure there's no RF, minimum RF being leaked out of these transformers to help with leakage, and is boosting the magnetic field. RF comes in, wraps around this transformer, creates an electromagnetic field. Got your 2 bias resistors just like the other one. Got your 2 feedback circuits just like the other one. Same thing, taking a little RF, putting it back into the input of the circuit. That helps to balance out a push-pull circuit for some reason. I don't know why. I don't know at all, y'all. I'm still learning. About done. Let me get my butt in the bed. We use metal caps right here because these capacitors get the hottest in the whole amplifier next to the output cap. These get the hottest, pretty much is the hottest of the whole amp. It's just because all of the RF at this point that's being created by the whole circuit is being created in this electromagnetic field, and it takes a lot more heat to keep as much leakage to not leak out of this transformer circuit here. A lot of people's next question is, what's the difference of the big transformers and the small transformers? The only difference in them is a little bit of inductance. That's all. You'll get into some things with some people. I've heard a lot from some reputable people that these big 5/8 core transformers, once they get hot, they lose their permeability a lot easier than the half-inch core transformers. Now, half-inch core can lose their permeability as well when they get hot, but it appears for some reason that the bigger transformers lose their permeability a little easier. And what will happen at that point is your RF will begin to splatter across the band a lot more, and less of your wattage is actually making it out of the amp. Okay, so same thing is, you got to wrap it around the output of this transformer. Sorry, I know it's bouncing back and forth. You got 120s right here, pill strip, which are to your collector, to ground. On the pill, the top is your collector. Kind of act like it's collecting all the RF that's going into it that's been amplified. It's the collector. The bottom is your base. That's the base. The bottom of the pill. The base. Sides are your emitters. You can kind of look at it. The sides are emitting the electrons from the ground to send into the pill to create what it needs to create. There's your power wire. We put ferrite beads on the power wire for one reason and one reason only: to keep AC off our DC. You use chokes on the AC to keep DC off your AC. So we're using the same thing to do the opposite thing in different situations. This right here is to keep AC off our DC line, so it won't travel on back through the wires on to wherever it's hooked up to throughout your car. Very important, man. As you see on this fat boy, there's not another choke on the output of the transformer. Having one there helps too. It's good to have a backup just in case. Same thing with this choke right here, trying to keep the AC off your DC line going to the output of the transformer. These chokes on the input of the transformers, those right there are to keep AC off your DC grounded line going to the ground. Okay? Because this right here is a DC ground of these transformers. I'm thinking because I believe that is correct. I'm about to run out of time. Might want to look up that just in case to make sure. I believe these are DC chokes to keep the AC off the grounding of this transformer, but I could be wrong. I need to double check on that. It's kind of late. RF goes around this out. Here's your output tune. At this point now, we're taking the signal that was put through all this and we're turning it back to 50 ohms. That's what this output cap is doing. Okay, and as you see, it solders to this lead right here. This is touching this. So this goes to here, out the amp, onto your antenna. That is the way RF flows through your circuit. There's a voltage regulator to keep this fan at the same speed at all times if you're on an unregulated supply, since the voltage will be fluctuating when keyed. The bead on there keeps the RF out of your fan. It keeps the RF out of your fan. You don't want RF in the motor of your fan. I hope this helps, y'all. Thanks for being patient with me. We'll get a more detailed video later. Gatekeeper. Appreciate you at 255. I believe it's 225, 255. Sorry, man. God bless, brother. Thanks for being patient.